All right, welcome back for another deep dive.
Yeah,
You ready to dive into some trigonometry?
absolutely. Always ready for some trig.
I know, I know. Trig, it might not be everyone's like favorite thing, you
Yeah.
know,
Yeah.
from back in school.
Yeah.
But we're going to uncover some cool stuff, I think.
I think so too. It's way more than just those formulas. It's like a key to how things work, really.
Ooh, a key, huh? Okay,
Yeah.
I like that.
Yeah. So we're going to be looking at trig equations, and by the end of this, I think you'll be able to solve them,
Okay,
but also really get what they mean.
okay.
Yeah.
All right, I'm intrigued. But let's back up just a sec.
Sure.
Trig equations, like what are they really?
Okay, so basically they're like puzzles, right?
Okay.
And you're trying to find these missing angles,
Hmm.
but they're not just any angles.
Yeah.
Yeah, they're connected to like these repeating patterns,
Like
waves and circles, oscillations.
So we're talking sine, cosine, tangent.
Exactly, all those fun trig functions.
Yeah.
And when you solve these equations, the angles we find, those solutions come in a few different, types.
Different types.
Uh-huh.
Okay, tell me more about that.
All right, so imagine like you're searching for a lost city, right?
Okay.
A principal solution, that's like your first clue on the map. It's an angle within a specific range.
All right, so that's like our starting point. What about the general solution?
Well, the general solution is like realizing that city might exist in many places across time.
Ooh.
Yeah, it's a formula that captures all the possible solutions. Because trig functions, they repeat. They're cyclical.
Okay, so that's like understanding the city could be rebuilt, rediscovered in different like eras.
Right.
Okay, and then particular solution.
That's like finding the city's exact location, like right now, a specific solution within a specific time frame.
Got it. So we've got our starting point, understand it across time, and then the specific location we need. That's a way better analogy than just definitions. All right, so how do we actually crack these trig codes?
Well, one really key strategy is factorization.
Oh, yeah, remember that.
Like imagine you're organizing a super messy toolbox.
Okay, yeah.
You want to group similar tools together.
Makes sense.
Makes things easier.
Any other tips?
Yeah, one thing to watch out for, try not to square trig equations unless you absolutely have to.
Oh, why is that?
It can lead to, like, these fake solutions, you know?
Oh, no.
Kind of like when you add too many ingredients and the recipe just like, ooh,
Goes wrong.
totally.
Yeah.
So always check your solutions by plugging them back into the original equation.
Good point. Double check, just like a good chef would.
Exactly.
Okay. So we've got factoring, but are there other strategies we can use?
Oh, yeah, tons. We've got quadratic equations, we've got auxiliary arguments, and then there are like these sum to product and product to sum transformations.
Wow. Okay. A lot to unpack there.
We'll get to it. But
Yeah.
first, I think we should touch on trig inequalities, too.
Trig inequalities. Okay.
Yeah.
Remind me what those are again.
It's like equations, but with a twist.
Okay.
So instead of just like one answer, we're looking for a whole bunch of values that work.
A range of solutions.
Exactly. And the key here is knowing the domain and range of those trig functions.
Oh, right. Those boundaries. Can we make that like a little more visual, maybe?
Totally. Imagine like a Ferris wheel. The height of the passenger, that's the output of our sine or cosine function.
Okay, I like that.
Yeah, and the highest and lowest points of the Ferris wheel, those are like the limits.
Okay.
So if you want to know when the passenger's like above a certain height.
You got to figure out like what angles on the wheel match that, right?
Exactly.
Right.
So understanding the range, it's like knowing those limits, and then we use that to figure out when the passenger is above or below a certain point.
Cool. It's like a visual map. Okay, I'm feeling a bit more confident about these inequalities now.
Good.
But maybe we should take a little break and then come back and really dig into some examples.
Sounds good to me. Let's do it.
Okay, so we were getting into some pretty cool strategies for solving these trig equations and inequalities.
Right. There's a bunch of them.
Yeah, feeling ready to put them to the test.
All right, let's do it. How about we start with one that uses factorization? Remember, it's all about grouping those like terms.
Okay, yeah.
Let's say we have the equation. 2 sine squared x plus sine x minus 1 equals 0.
Okay.
Looks a little scary at first, but look closer.
It does kind of look like a quadratic equation, right?
You got it. It's like those from algebra.
Yeah, yeah.
And we can use that. Let's swap out sine x for a simpler variable like y.
Hmm?
So now it's 2y squared plus y minus 1 equals 0. Looks more familiar, right?
Way more.
Now we can factor it like a regular quadratic. So it becomes 2y minus 1 times y plus 1 equals 0.
Okay, I see that.
Now we just pop that sin x back in for y.
Oh, yeah.
Gives us 2 sin x minus 1 times sin x plus 1 equals 0.
So we got two factors now. To find the solutions, we set each one to 0.
You got it. And then we solve for sin x, then use the inverse sine function to get our angles.
Wow, that's cool. Using a simple swap, we turned like a tough trig equation into an easy algebra one.
Exactly. Math is all about finding those connections.
I never realized how linked they are.
All right, let's move on to another strategy. How about auxiliary arguments?
Ooh, what's that?
Think of it as like calling in a specialist
Okay,
to help us solve a tough problem.
right?
So let's say we have sin x plus cosine x equals 1.
Okay, yeah, this one's a bit tougher looking.
This is where our auxiliary argument comes in. It lets us bring in a new angle. Let's call it A.
We're adding another angle. How does that even help?
It might seem weird, but if we choose this A angle just right,
Yeah.
we can rewrite the left side as one single trig function.
Yeah.
Like combining two ingredients into like a whole new flavor.
Ooh, I like that. So
Okay.
we simplify it by adding something in.
Exactly. It's a really neat trick for those tougher equations.
Okay, I can see how that would be useful. What about those transformations? Sum to product and product to sum.
Those are like rearrangements. Sometimes an equation is just easier to solve if we like swap a sum for a product or the other way around.
So it's not changing the equation,
Mm.
just rearranging it.
Right. Like rearranging furniture.
Yeah, I get it. So we're just making it easier to work with.
Exactly. It can open up new ways to find the solution.
I like how it's not just about like memorizing formulas.
Right.
It's about really getting how they all work together.
Totally. So ready to tackle those inequalities. Remember the Ferris wheel?
Oh, yeah, that was a good one.
It's perfect for picturing inequalities with sine and cosine.
Okay.
Remember, passenger height is like the output, the Ferris wheel spinning is the angle.
Mm-hmm.
So let's say we've got sine x greater than 1/2.
We want to find all the angles where the passenger is higher than halfway up.
Exactly. If we look at the unit circle or even just picture the Ferris wheel, sine x equals 1/2 at 30 degrees and 150 degrees.
Yeah. Well,
And we want it greater than 1/2. So our solution has to be all the angles between those two.
so it's not just one angle, it's a whole range that fits.
Right. And remember, trig functions, they repeat. So our answer needs to include all those angles even as the Ferris wheel keeps going.
Right, because the passenger keeps going higher than halfway every rotation.
So we express it like this. 30 plus 360n is less than x is less than 150 plus 360n, where n can be any whole number. It covers all the possible angles.
Wow, okay. We went from a Ferris wheel to, like, infinite possibilities.
That's trig for you. It lets us link simple pictures to these big concepts.
This has really changed how I see trig, you know?
That's awesome to hear.
It's not just triangles and angles, it's about the patterns and how they work in, like, the real world.
Absolutely. So are you ready to see some real-world examples?
Oh, yeah, let's see how this all comes together. Okay, so we've been talking about these equations and inequalities, all this trig stuff.
Yeah.
But I want to know how it, like, works in the real world, you know?
Oh, for sure. Let's start by, like, looking up.
Dumb.
Yeah, ever wonder how they figure out how tall, like, a skyscraper is? Or a mountain?
I always just figured, like, giant tape measure, honestly.
Nope. They use trig. Imagine you're standing a certain distance from a building,
Okay.
and you measure the angle, like, from your eye up to the top. You
Yeah.
got a right triangle there.
Oh, right. So the building's height is one side.
Exactly.
My distance is another.
Uh-huh.
And then the angle I measured.
Wait, that's where those trig functions come in, right?
Bingo. The tangent of that angle, it's the building's height divided by your distance?
So I can figure out how tall it is just with an angle and, like, knowing how far away I am?
Pretty much.
Yeah.
A little trig magic, and you don't even need to climb the thing.
That's so cool. Like, hidden math everywhere.
Right. What about GPS? Okay, yeah, GPS. My phone gets those signals, but how does it know exactly where I am?
Triangulation, my friend. And guess what?
More trig.
More trig. Your phone figures out how far it is from, like, at least 3 satellites.
Okay.
Those distances plus the satellite positions make triangles.
Oh, right. And then using those triangles, it figures out where I am on the map.
Exactly. It's like invisible triangles guiding you around.
That's wild.
Yeah.
But is there trig in, like, less technical stuff?
Oh, yeah. Think about music.
Music.
Yeah, sound waves, they're the basis of music, right?
Mm-hmm.
Well, you can model them with sine waves. Each note has a frequency, that's its pitch, and those frequencies, they're sine waves, different amplitudes, different wavelengths.
Wait, so the music we hear is just like a bunch of trig functions combined?
Pretty much. And even the instruments like guitars or violins,
Yeah.
they use these things called standing waves, and those are totally tied to trig.
So music isn't just like art, it's math too.
It's both. Math and art all mixed up. It's pretty amazing.
This is blowing my mind. So we've got buildings, GPS, music.
And that's not all.
Mhm.
Architecture, engineering, astronomy, even like computer graphics.
Arc is everywhere.
It helps us understand the world, you know? And build stuff, create stuff.
I did not realize how powerful trig is, honestly.
It's all about understanding the ideas, not just the formulas.
Right, yeah, the bigger picture.
And how those ideas connect to, well, everything.
So to everyone listening, thanks for coming along on this trig journey with us.
Yeah, thanks for listening.
Hopefully you see how cool this stuff is now.
And how it's used in the real world.
Keep being curious, keep asking questions,
Yeah.
and you'll find even more amazing uses for trigonometry.
Absolutely.
Catch you on our next deep dive.